Yeah, welcome to the next video lecture on TRIAC. TRIAC, the expansion is triode for alternating current. So, in the previous lecture, we have seen DIAC, that is diode for alternating current. Now, this is TRIAC, triode, that means it has three terminals, right? Triode for alternating current. Now, this is very important device which is widely used for switching medium power alternating current supplies. And the major advantage is that it can switch between the two halves of the alternating cycles, right? So we see the symbol of the TRIAC. The symbol of the TRIAC, you can see here, the symbol of the TRIAC where it has three terminals. So MT1 main terminal 1, MT2 and gate. Now next, TRIAC equivalent circuit by using SCR. So silicon, now we can implement or we can draw a circuit of the TRIAC using the silicon control rectifier SCR. Now this is the figure where two SCRs are being used in parallel and they are kept in reverse direction, but the gate is taken in common, right? So we get as MT1, MT2 and the gate. So this is the equivalent circuit of the TRIAC by using SCR. Now this is better, I believe, right? Fine. The next, now we see the construction of TRIAC. Now if you can see the construction of the TRIAC, now we can see here that how many layers it possesses, all that. Now it is a 4-layer device that consists of 6 doping regions. So TRIAC is a 4-layer device that consists of 6 doping regions. The gate terminal is designed in a way to have a ohmic contact with both N and P regions of the device, which helps the device to get triggered with both positive and negative polarities. Now we can see the principle of the TRIAC. Now the TRIAC can go to the conduction state if the applied voltage is equal to the breakdown voltage. But the preferred way is that we have to apply the gate pulse, right? Now if you can recall the DIAC operation, in the DIAC operation it is enough to apply a potential across MT1 and MT2, and if the potential is greater than the breakdown voltage, now the DIAC will be conducting. Similarly, here it is here similarly, but with one small constraint, that if you apply a potential between MT1 and MT2, that will not be sufficient, but you have to provide a gate pulse. This is very important because you are going to control the TRIAC like a switching device. So you are going to provide a gate pulse, which is the gate pulse, that is pulse signal will be given to the gate terminal. Either the pulse will be the negative pulse or the negative pulse, right? Now and the gate current is very high, and it is enough for the TRIAC, that is the external supply voltage between MT1 and the MT2 can be small enough, the TRIAC will start conducting, right? Now the TRIAC is a bidirectional device, as we have seen. As the DIAC, it is also a bidirectional device, and it has the ability to turn on with both the polarities to the gate pulse, right? And it is having 4 modes of operation. So TRIAC has 4 modes of operation. Now coming to the modes of operation, now here we can see the modes of operation, how it has been designated. Now, the first one is the main terminal 2 is given to the positive supply of the battery, and the MT2 is connected to the negative supply of the battery. That means we call that as MT2 is positive with respect to MT1. It means that MT2 is connected to the positive terminal of the battery and MT1 is connected to the negative terminal of the battery, and with a gate polarity positive with respect to MT1. That means a potential is applied between the gate terminal and MT1, where the gate terminal at the, that is the gate is given the positive terminal of the battery and the negative terminal is connected to MT1. And similarly, in the second mode we can see MT2 is positive with respect to, now it is same, the second mode is same, only the difference is the gate is negative, right? And the third mode we can see MT2 is negative with respect to MT1 and the gate is positive, sorry, negative here we have taken. The fourth one we have taken MT2 is negative with respect to MT1, only the difference is gate is positive polarity with MT1, right? Now here we are having uh, four modes of operation. Now we just go with the first mode of operation. In the first mode of operation, as I told you, that you have MT2 will be positively connected to the battery, and then MT1 will be connected negatively, and then you can see gate is connected to the positive, right? And then the negative of the gate supply is given here, that is the VGG is given to the N2, right? This is the first mode where the flow of the current will be from P1, N1, P2 and N2, right? Then, now this is the first mode of operation. The second, now the next second mode similarly, now MT2, MT1, the same VMM we have taken, right? This is positive, the same connection, only here we have reversed the terminal, that is gate is connected with the negative terminal and MT1 is connected to the positive terminal. Now see the flow of the current, it will be from P1 to N1, P2 to N2, right? And similarly the next mode, third mode, similarly here MT2 is given to the negative terminal and the positive terminal is given to the MT1. The gate is positive, right? So it is positive here. The previously I told as negative, right? Here it should be as negative, right? Negative, and the next one as positive, right? Right. Then fine. This should be like a positive, right? Now this is about the fourth mode. Fine. Now these are the four modes of the TRIAC. Fine. And then which mode is to be used? Now in order to use which mode can be better used for the TRIAC? Now we can see that the second mode and the third mode can be better used for the operation of the TRIAC. TRIAC it is, okay. And then the VI characteristics of the TRIAC, if you can see, now it will be similar to the DIAC VI characteristic, only that the, now that means it will be having the blocking state and the conducting state, okay. Now this is for the MT2 positive and here MT2 negative, right? Now this will be the first quadrant. In the first quadrant similarly it will be having the blocking state, and then after a breakdown voltage the current will be increasing, and it will be depending upon the gate current. Fine. Then next, right? Now as I told you, right, it has and then we just go move on to its application, which is very important. So TRIAC has various applications. TRIAC it is commonly used to switch AC voltages and control switch. It is used to control various appliances like fan, electric fan, and the motor control, right? And it is used for high power lamp switchings and the dimmers, and it is used for AC power control domestic appliances, right? Now this is about the entire TRIAC and its applications. Hope you enjoyed this video, right? We will come with another video in the next class. Thank you.